This is section 10.5, surface area of pyramids and cones. These are the objectives, vocabulary. You can pause to read them and copy them. I am moving on to the next slide. Follow along. The vertex of a pyramid is the point opposite to the base of the pyramid. So this is the base of the pyramid. So this is the vertex of this pyramid. And the same thing for this other pyramid. The base of a regular pyramid is a regular polygon, and the lateral faces are congruent isosceles triangles. So these triangles that you see here, they are congruent isosceles triangles. Every single triangle here is congruent because the base is a regular pyramid. I mean, it's a regular polygon. The slant height of a regular pyramid is the distance from the vertex to the point of the edge of the base. So this is the slant height, and we'll be using this to compute surface area. And the altitude of a pyramid is the perpendicular segment from the vertex to the plane of the base. So this is what we're talking about. This is the altitude of either pyramid. Let's move on to the next slide. Here's a formula on how you're going to compute the lateral and the surface area of a regular pyramid. To compute the lateral, all you need is the perimeter of the base and also the slant height. To get the lateral, follow this formula, half PL. And the surface area of a regular pyramid with lateral L and base area B is basically whatever the lateral is plus the area of the base. Or you should be able to follow this formula. Let's move on to the next slide. Here's number 1. It says find the lateral area and surface area of the regular pyramid. Round to the tenths if necessary. So the first thing you're going to do is you're going to find the lateral area. So you need the perimeter times the slant height divided by 2. So let's find the perimeter, and you should see that it is 60, 6 sides. This is a hexagon. The side is 10. Then we use this formula, L is equal to half PL. The perimeter 60, the slant height is 16. Simplify this, and this is the lateral area. Now let's go, step 2 is to basically find the surface area, which is the lateral plus the base. So to find the area of the base, I need to know the apertum, and you should see why. I'm basically applying what we did in what we used in chapter 9. Compute half the center angle. This is 5, 30, 60, 90. If the short leg is 5, the long leg is 5 radical 3, or you can use the trig ratios, and you're going to be working with the decimal. But the apertum is 5 radical 3 inches. So now I apply the formula for a regular polygon. So 1/2 apertum times perimeter. Substitute the numbers, and this is what you get. Now add those two, and this is your answer. Let's move on to number 2. It says find the lateral area and surface area of the regular pyramid. First, find the lateral area. So it's 1/2 PL. Notice that you can find the perimeter very easily, but we do not know the slant height. We need the slant height here. So first, perimeter 64, 4 times 16. Then here's the slant height. If you draw a right triangle here, you know that this is 15, this is 8 because it's half of 16, and you're able to find the hypotenuse using the Pythagorean theorem, and that is your slant height. Now that you know your slant height, find the lateral, simplify, 544. Step 2 is to find the surface area. Is the lateral plus the base. 16 squared because that's the area of this base. 16 squared. Add those two numbers, you get 800 square feet. Let's move on to the next slide. Terms that you should know. First, the vertex of a cone is the point opposite to the base. So here's your base. This is the vertex of this cone. In the same manner, here's the vertex of the other cone. The axis of a cone is a segment with endpoints at the vertex and the center of the base. So these are your axes of a cone, and the axis of a right cone is perpendicular to the base. The last part is the axis of an oblique cone is not perpendicular to a base. As you can see, this is not perpendicular. This one is. And this is what we call an oblique cone. This is a right cone. Next slide. This is how you're going to be computing the lateral and the surface area of a right cone. Notice that if you were to create a net out of this cone, this is what you get. A circle in this shape, which sort of looks like a Pac-Man. Follow along. So the lateral is just going to be pi RL. L is the slant height, which is what you see here. R is just the radius. Now the surface area is going to be the lateral plus the base. But if you look carefully, the base is a circle. That's why you see pi r squared. The slant height of a right cone is the distance from the vertex of a right cone to a point on the edge of the base. And I highlighted that earlier. So this is your slant height. And it follows this definition. And the altitude of a right cone is a perpendicular segment from the vertex of the cone to the plane of the base. So this is the altitude of the right cone. And again, it follows this definition. Let's move on to the next slide. It says find the lateral area and surface area of the cone. So let's apply. First, we need to find L, which is the slant height. I'm going to use the Pythagorean theorem, and that's why you see that there. And it turns out to be 17. From here, the lateral is just pi RL. Pi times the radius times the slant height. That's why you see those numbers. Simplify, you get 136 pi square inches. To find the actual surface is the lateral plus the base. So that's why you see pi r squared, because the base is a circle. Simplify this, add it to 136 pi, and you end up with 200 pi square inches for the surface area of this cone. Number 4, again, lateral and surface area. First thing is we need to find the radius. This is 24, and this right here is 25, which is the same distance that you see here. And if you apply the Pythagorean theorem, you end up with 7 for the radius. Then the lateral is the following after you substitute 175 pi. The surface is the lateral plus the area of this circle, which is the base. And that's how we end up with 224 pi square inches. Let's move on to the next slide. It says the base edge length and slant height of the regular hexagonal parent are both divided by 5. Describe the effect on the surface area. So here, this is the shortcut. By now you should feel comfortable doing this. This is both divided by 5. Okay, so describe the effect on the surface area. We're still talking about area, so you should see something raised to the second power. So this is the effect. The surface area is divided by 25, which again is 5 squared, or multiplied by 1 over 25. And this is the answer to number 5. Again, the shortcut, just take this number, square it. Since you're dividing, so divide by 25 or multiply by 1 over 25. Next slide. This is find the surface area of the composite figure. So first thing we're going to do is we're going to find the lateral at the top, which is what you see here. These 4 triangles in the top. So it's 1/2 PL. 1/2, 32 is the perimeter, since each side here is 8 units and the slant height is 15. That's why you see these numbers here. You get 240 square feet. Then you're going to find the lateral at the bottom. Very similar steps. The only thing that changes is the slant height is 18. So the total surface area is by adding these 2 numbers, and you end up with 528 square feet. Next slide. This is the last one. Same directions, surface area. Notice that you see 3 different shapes. So we're going to find the lateral of the top, which is just pi r L. The radius is 12. The slant height is 26. That's why you see those numbers there. You get 312 pi square meters. Now the lateral of the center, which is basically just the lateral of the cylinder. And you should remember this from a previous section. It's just pi RH. Substitute the radius and the height of 15, and you end up with 360 pi square meters. The lateral of the bottom is pi RL. Same formula as the top, different numbers. It's actually different slant height. The radius is the same, and you end up with 384 pi square meters. So the total surface area, we add these 3 numbers, and there's your answer. And this concludes the video.